All right, so you're going to use this with worksheet number 1 for topic 28. And so those problems are very similar to that worksheet. Now, notice that part 1 says determine whether each of the following functions are one-to-one, and then just write yes or no. Well, when you study the videos, you're going to learn what a one-to-one function is. So let's talk about the inverse of a function. So one of the things you're going to learn when studying those videos is that a function that is a one-to-one function has an inverse. And so first of all, let's remind ourselves what a function is. So remember, a function is a relation in which for each x coordinate, there's only one y coordinate. Now, here's the new one. What is a one-to-one function? Well, a one-to-one function is a function. First of all, it has to be a function. And if it's a function, it is one-to-one if for each y coordinate, there's only one x coordinate. So notice the difference between those two. So a function says for each x coordinate, there's only one y coordinate. A one-to-one function is just the other way around. For each y coordinate, there's only one x coordinate. All right, so remember, a function for each x coordinate, there's only one y coordinate. A one-to-one function is the other way. So you're going backwards if you want to think about it that way. For each y coordinate, there's only one x coordinate. Okay? All right, so let's go ahead and look at the first one and see how that applies. So this says determine whether each of the following functions are one-to-one. And so you want to write yes or no. All right, so let me remind you what you did in the past. So remember now first of all, you're told this is a function. But if you were not told this is a function and you were asked, well, or is this a function, remember what you did. So what you did was you took this in terms of a mapping, x and y. So when x is 6, y is 3. When x is 2, y is 1. When x is -4, y is 6. When x is 3, y is 8. So remember, for each x coordinate, you see only one y coordinate. So that's a function. So but you're told it's a function to begin with. But now what we're interested in, is it a one-to-one function? And when looking at a one-to-one function, you're just going the other way. So instead of starting with x, you're going to start with y, because that's what this says. For each y coordinate, there's only one x coordinate. So the way you're going to do this is this way. So you're going to do the mapping again. It does help. But instead of putting x first, you're going to put y first, and then you're going to put x. So to determine the function, you put x and y, and you drew your arrows going from x. For one-to-one, you're going to put y and then x, and you go from y to x. So this way you're going to do it. So let's look at the first point. This is your x, this is your y. So if y is 3, see how I put the 3 here? It gets mapped to 6. So when y is 3, my x value is 6. The next point, when y is 1, my x value is 2. When y is 6, my x value is -4. When y is 8, my x value is 3. And so notice that for each y coordinate, there's only one x coordinate. For each y coordinate, there's only one x coordinate. And according to the definition of a one-to-one function, for each y coordinate, there must be only one x coordinate. So this is a one-to-one. So this function is one-to-one. So it's a one-to-one function. So when you study the videos, you're going to see more examples like these. Now let's look at the next one. So in the next one, you have 1, 2, 3. You have 5 points here. So let's again do the mapping. So y, x. Now remember, when you're asked about is this one-to-one, always make sure you put y first, and then x. So when y is -3, my y value is 5. When y is 2, my x value is 6. When y is 4, my x value is 8. When y is 5, my x value is 0. When y is negative 3, now remember, only listed once. So you see negative 3 is already listed, so don't list it again. You're not going to understand this correctly if you list it again. So when y is negative 3, my x value is 9. So you're doing this. All right, now remember, it says for each y coordinate, you can only have one x coordinate for a one-to-one function. So notice when y is negative 3, there are two x coordinates, 5 and 9. So this means that this is not a one-to-one function. All right, so by the definition of a one-to-one function says that for each y coordinate, there's got to be only one x coordinate. And so according to this, remember, in talking about one-to-one, always put y first and x. This is an x right here, and x in this mapping right here. And so notice when y is negative 3, there are two x coordinates. So that's not a one-to-one function. So notice in part A and B, you were given a set of ordered pairs. In C, you're not given a set of ordered pairs. You're given an equation. So you're given this function. But hopefully you notice that this is a linear function. So you noticed that this is a linear function. All right, now if you didn't, it's still okay, but hopefully you did, because you worked on linear functions quite often. All right, the way we're going to look at this, there's a couple ways you can look at this. You can look at this in terms of a t-table. All right, in terms of the t-table. Now remember, h of x means the same thing as y. So let me go ahead and rewrite this here. So h of x equals 2x minus 4. So that's the same thing as saying y equals 2x minus 4. So when x is 0, you just plot in some points, just like we did here. You have a set of ordered pairs. So when x is 0, my y value, 2 times 0 minus 4, is a negative 4. When x is 1, I'm just picking some numbers for x. When x is 1, I get 2 times 1 minus 4. So 2 minus 4 is a negative 2. When x is negative 1, 2 times a negative 1 is a negative 2. A negative 2 and a negative 4 is a negative 6. And I'm running out of room. When x is, let's say, 2, I get 2 times 2 is 4. 4 minus 4 is 0. So let's look at what we have, though. I ran out of room, and this is about enough. That's about all the points I need. You need to try and get at least, whenever you give an equation, try and do at least 4 or 5 points. So I want you to notice something. If I do that mapping like I did here, so y first, x next. When y is negative 4, my y value is 0. When y is negative 2, my x value is 1. When y is negative 6, my x value is negative 1. When y is 0, my x value is 2. So notice for each y coordinate, there's only one x coordinate. And according to the definition of a one-to-one function, for each y coordinate, you can only have one x coordinate. And that's what we have here. For each y coordinate, there's only one x coordinate. So this is a one-to-one function. Now that's going to be important. The fact that it's a one-to-one function means that it has an inverse. We're going to talk about that in a little while. It's going to have an inverse if it's a one-to-one function. And that's what we saw earlier. A function that is a one-to-one function has an inverse. Okay, now the other way you can look at this is in terms of a graph. So let me just kind of do a rough sketch of this just to show you another way to look at this. So you know this is a line. You know that's a line. And so I'm going to plot a couple of these points. So I'm doing it by hand, so it's not going to look good. So if x is 0, y is negative 4. So 0, negative 4, right here. And then if x is 1, y is negative 2, right here. Now remember, this is a line, right? So all you need are 2 points to graph a line. So here's my line. Now remember, you note this is a function, correct? You know this is a function. This is a function because it passes the vertical line test. All right, the vertical line test. So notice no matter where I draw that vertical line, it will cross it only once. Okay, so we know it's a function. And we knew it was a function because of this function notation. But the question is this function a one-to-one function? A one-to-one function. We know it is because of what we just saw. We looked at this in terms of a mapping. For each y coordinate, there's only one x coordinate. But I wanted to show you a different way. So remember a while ago we said this is a function because it passes the vertical line test? Well, there's such a thing as a horizontal line test. Horizontal line test. All right, so remember, vertical line test helps you to determine if the graph represents a function. The horizontal line test helps you to determine if the function is a one-to-one function. So the horizontal line test helps you to determine if the function is a one-to-one function. So remember, the vertical line test crosses only once, so it's a function. Look at the horizontal line test. And no matter where I draw this horizontal line, it intersects the graph once each time. And what that means is this. For this y coordinate, there's only one x coordinate. For this y coordinate, there's only one x coordinate. For this y coordinate, there's only one x coordinate. So the horizontal line test helps you determine if the function is a one-to-one function. If the horizontal line crosses the graph once, everywhere, then the function is one-to-one. Then the function is one-to-one. Now, another way we can abbreviate one-to-one is just saying one-to-one like this. So notice it's a one-to-one function. It passes the horizontal line test, so it's a one-to-one function. So let's look at another graph. Look at this one. Look at D. So is this, now you notice this is a function, right? An absolute value function. So that looks like an absolute value. But is this a one-to-one function? So the question is this function a one-to-one function? That's the question. And if I use the horizontal line test, so look, no matter where I draw that horizontal line, except here, but it only needs to fail it once. So notice that it crosses the graph twice here. So that means that if I look at these 2 points right here, for this y coordinate, there are 2 different x coordinates. There's an x coordinate here, and there's an x coordinate there. So it fails the vertical line test. So this function fails the horizontal line test. So it is not a one-to-one function. All right. Now you can look at it in terms of another way. So watch at it this way. So let me go ahead and draw and write a absolute value function. So let's suppose we had this. H of x equals the absolute value of x plus 2, let's say. All right. Now, in a previous lesson, you had to graph something like this. Remember when you talked about transformations? You had to graph this. So in your mind, you know what this looks like. In your mind, you know that this looks like this, right? And so right away, you know it fails the vertical line test. So sometimes if you know what the graph of a function looks like, you can easily determine if it's a one-to-one function. So we know this is not a one-to-one function, but I want to talk about this in terms of a set of ordered pairs. So if x is 0, the absolute value of 0 is 0. 0 plus 2 is 2. When x is 1, the absolute value of 1 is 1. 1 plus 2 is 3. When x is negative 1, the absolute value of negative 1 is 1. 1 plus 2 is 3. Right away, I'm done. Because look, when y is 3, I get this x value, and I get negative 1 is the x value. So remember, definition of a one-to-one function says that for each y coordinate, there's only one x coordinate. So notice that when y is 3, there are two different x coordinates. So this is not a one-to-one function. Okay? All right. Now, let's look at the next part. Okay, so, all right. Now, here, this is what you're asked to do. So on that worksheet, you will be asked to determine the inverse algebraically. So we know that this is a function, all right, and so these functions that you're given will have an inverse. And so the question is, well, how do I determine this algebraically? All right, I'm about to show you the step. It's very simple. As I go through this one, though, remember the inverse undoes what the function does. So let's just kind of write it like this. It undoes what the function does. All right. So meaning this. So watch what I'm, or listen to what I'm saying, and then as we go through the process, you'll see it. So notice that this function takes x, multiplies it by 6, and subtracts 3. Okay? So this function takes x, multiplies it by 3, and subtracts 3. Right? It kind of makes sense because if you do a t-table, if you would do a t-table, if x is 0, you say 0 times 6, which is 0, and then subtract 3. So you multiply by 6 first, and then you subtract 3. So you get negative 3. If x is 1, you would say 1 times 6. So you multiply by 6 first, and then subtract 3. So that's 3. So remember the order of operations. You're going to do multiplication and then subtraction. If x is, let's say, negative 1, you're going to say 6 times negative 1, which is negative 6, and then when you subtract 3, you get negative 9. And you can continue on. But the intent here is for you to understand what we mean by undoing. So the inverse basically does this. So the inverse, I'm going to write it in words. So the inverse will take the value of x. All right, the inverse, you do the opposite. So listen carefully. So the first thing we did was we multiplied by 6, and the second thing we did was we subtracted 3. So you're going to go backwards. So instead of subtracting 3, you're going to add 3. So it'll look like this. So you take x and you're going to add 3. Instead of multiplying by 6, the opposite of multiplying by 6 is to divide by 6. And this is the inverse. So this is the inverse of f of x. All right, so in words, this is what you did to a linear function. So the function f takes x, multiplies it by 6, and then subtracts 3. The inverse does the opposite. So it's going to add 3 to x and then divide by 6. So let's see how this looks algebraically. So here are the steps. So when you look at the lessons, they're going to mention some steps. So let me go ahead and show you what those steps are. Very simple. So these are the steps. So these are the steps for finding the inverse algebraically, the inverse of a function algebraically. Step 1, you're going to replace f of x with y. Step 2, you're going to interchange the variables. So where we see an x, you replace with y. Where we see a y, you replace with x. Then you solve for y, and then you replace y with this notation. Now, this notation does not mean f to negative 1 power. You read this is read as f inverse of x. That's how you read this, f inverse of x. Okay? So this negative exponent up here with this notation that looks like a function, you read it as f inverse. That's how this is read. All right, so step 1, replace f of x with y. Step 2, you interchange the variables. Step 3, once you interchange the variables, you solve for y, and then whatever y is, you replace it with this, and that's the inverse. So let's go back to the first one. This one right here. All right, so let's do this algebraically. All right, so step 1, replace f of x with y. So y equals 6x minus 3. Step 2, interchange the variables. Y becomes x becomes y. Step 3 is to get y by itself. Now, step 3 is where you're going to have to do a little bit of work. So to get y by itself, I'm going to add 3, right? So you're going to add 3 to both sides. So let me go ahead and rewrite this like this. So you're going to add 3 to both sides. And remember when we had the discussion? Isn't that what we did here? See this x plus 3 right here? Isn't that what we had here? So we said you just, the inverse undoes what the function does. So you're going to go backwards to undo it. All right, so I get x plus 3 equals 6y. And then to get y by itself, I divide by 6. And so I get y equals x plus 3 divided by 6. You see this right here? That's what we got, right? When we talked about it in terms of words. Now, step 4, though, to indicate that inverse, see it says find f inverse, so you must say f inverse of x equals. So you got to write this. So step 4 is replace this with this. F inverse of x equals, and then there's your answer. X plus 3 divided by 6. All right, so there's your inverse. So the inverse of this function is this function. Makes sense because this function takes x, multiplies it by 6, subtracts 3. The inverse does the opposite. Adds 3, divides by 6. All right, so that's what we mean by inverse, by the inverse of a function. So it undoes what the function does. And these steps actually does that. So these steps not only works for a linear function, it also works for any other function. Like let's do this quadratic. So in your worksheet, you're going to have a quadratic function to deal with. Now, let me say something, and this will be important. So listen carefully to this. I am going to draw a rough sketch of this function right here. F of x equals x squared minus 6. Now, using transformations in your mind, you know what this looks like. This looks like this. You can take x squared and you're going to shift it down 6. 1, 2, 3, 4, 5, 6. So it looks like this. So you see, this is f of x. But here's the problem, and you're going to learn about this in those lessons. Here's the problem. Is this a one-to-one function? It is not a one-to-one function because it fails. See, it fails the the horizontal line test. So this by itself is not a one-to-one function. And so if this is what you're looking at, if you're looking at this graph right here, which represents this, then we cannot talk about an inverse. But then you ask, well, why are you asking to find an inverse here? because of this right here. So you will notice in some of the problems you're going to deal with, if the function itself, this right here, originally is not a one-to-one function, it doesn't have an inverse, we restrict the domain. So this function, the domain of f of x is restricted. So as you look at the lessons, you're going to see that word restriction. So it is restricted. You see the domain here is from negative infinity to infinity. Because the domain is negative infinity to infinity, it's not a one-to-one function. So what we do here is to make this a one-to-one function, we have to restrict the domain. So see where I have x is greater than or equal to 0? So x is greater than or equal to 0 here. So here's where x is 0. So greater than 0 is looking at this. So you're taking away this part here. And so notice when I draw this over right here, this side right here, this piece is now a one-to-one function. So that is one-to-one. And so that's what's happening here. So you'll see situations like this where you'll see a restriction. Here you did not. So you didn't see that here. But here you do, because the graph of this right here, is this, and that's not one-to-one. So if you want to make it one-to-one, you have to restrict the domain. So now becomes this, which now has a one-to-one function. So when you go through the lessons, you're gonna hear that again. But needless to say, you're asked to find the inverse algebraically. All right, so let's go through the steps. Step 1, replace f of x with y. So y equals x squared minus 6. Okay? Step 2, interchange, remember step 2, interchange the variables. So y becomes x becomes y, just like this. Step 3, solve for y. Now notice this, see in the previous problem, you had a linear situation. Here, you have a quadratic. All right, so we're going to get y by itself. At some point, I'm going to have to take the square root of both sides. See, you're squaring y. So I'm going to add 6 to both sides. So I get x plus 6 equals y squared. All right, now be a little bit careful with this now. So let me go ahead and rewrite this over. So in the past, what you've done, whenever you took the square root of both sides, do you remember doing that plus or minus? You remember that, right? You don't do that here. Do not do that here. And here's why. Okay, so listen carefully. I restricted the domain, so I'm only looking at part of it. So what's happening is this. Listen carefully. So when I restrict the domain, I'm only looking at this side right here. Okay? I'm looking at this side. So notice that x here is greater than or equal to 0. That's the domain. X is greater than or equal to 0. And the y value, see this is 6, negative 6 right here. Negative 6. So this is negative 6. And the range is from is negative 6 or larger. So greater than or equal to negative 6. Okay? So when you take the square root of both sides, you're only using the positive square root, not the negative. You're only using the positive square root. Okay? You're only using a positive square root. So you're going to say y equals the square root of x plus 6. So that's the one you're going to use. Don't do plus or minus. You're only doing the positive square root. So step 3 was to solve. So step 3, I kind of did step 2 and step 3 together. Step 4 is now you replace y with the inverse. So f inverse of x equals the square root of x plus 6. All right, so now that one was a little bit more difficult than the previous one, because at this point, many of you would have said plus or minus, and it's not plus or minus. for the reason that the domain was restricted. So you got to be careful with that. All right. Okay. So there's the answer to that one. Now there is a problem on the worksheet. So go through this when you do the worksheet. Go through this to help you go through the steps. All right. Just remember that don't do plus or minus because it's no longer correct. Remember, you are restricting the domain, so you got to be careful. All right. So that's letter B. Let's look at C. All right. Now, x cubed. Let's look at x cubed minus 4. So a rough sketch of x cubed minus 4 looks like this. So x cubed minus 4. In terms of transformations, you're taking x cubed and you're moving it down 4. So 1, 2, 3, 4. So it looks something like this. X cubed minus 4. So this is h of x equal x cubed minus 4. Notice it passes the horizontal line test. So it's already a function. So that's why you don't see any restrictions. You don't see any restrictions here like you did this. Because x squared minus 6, when you looked at the parabola, that was not a one-to-one function, so we had to restrict. Here you don't. All right? So that's why you don't see a restriction, because this function is already a one-to-one function. And all you do now is just algebraically find the inverse. All right, so let me go ahead and rewrite this. Now watch how simple this is. Step 1, replace h of x with y. Y equals x cubed minus 4. Step 2, interchange the variables. X equals y cubed minus 4. Step 3, solve for y. So at some point, I'll be taking the cube root. So I'm going to add 4 to both sides. I'm going to rewrite this over. X equal y cubed minus 4. So I'm going to add 4 to both sides. So I get x plus 4 equals y cubed. Then I'm going to take the cube root of both sides. Cube root of both sides, just like this. And the cube and the cube root and the cube undo each other. So you get y equals the cube root of x plus 4. And there's the inverse. So step 4 is to replace y with the inverse. Now be careful, don't say f inverse, because this is h. So you got to say h inverse. So h inverse of x will equal the cube root of x plus 4. All right, let's look at D. Don't let D throw you off. It's a very simple problem. So let's find the inverse. You want to find G inverse. All right, so here's how you can do this. So step 1, replace g of x with y. So y equals x minus 5 divided by 6. Step 2, interchange the variables. X equal y minus 5 divided by 6. Step 3, solve for y. All right, so let's remember how to solve for y. Let me go ahead and rewrite this over. So if I want to get y by itself, right now I'm dividing by 6. So the LCD is 6, and multiply both sides by 6. So I get 6x equal, and these divide out, so I get 6x equals y minus 5. And then finally all I do is add 5 to both sides, and so I get 6x plus 5 is equal to y. Once you get y by itself, that's your inverse. So step 4 is to tell me what the inverse is. So G inverse of x equals this right here, 6x plus 5. All right, and it kind of makes sense because remember, though we're saying this and this are inverses. So let's think about this right here. If I look at the inverse of this, this says that the inverse undoes this. So it subtracts 5. You see this 5 up here? Subtract 5, and then divides by 6, and that's what you see here. So those are inverses. So it kind of makes sense what I have here. All right, so that's D. All right, so that is that worksheet you're going to see. So that 28, that worksheet you're going to have to do is this. So I worked some problems very similar to what you have to deal with. All right, so that was the the some examples for that work she's going to do. So I'm going to end this little part here.